distribution. We have 4 scores. So remember, if these are my scores, every good dot plot has a number scale that counts by the same amount. This should be a pretty easy number scale to write down, right? These are all my exam scores. Those are as a percentage. And then the title, this is the population of my fake 5th hour exam scores. And then I have 1 score of a 60, 1 score of a 70, 1 score of an 80, and 1 score of a 90. I want to remind you that this individual dot represents 1 individual score of a 90. In my 5th hour, right? And that should be pretty self-explanatory, but it is a big concept when we're going to move towards what we're going to be learning in this chapter. We're going to talk about sampling distributions and some important stuff. So once again, if we were making a dot plot of my population distribution, my population was only 4 students, so that's why I only have 4 dots there. And it says take a sample of any of the 2 scores and then find the mean of your sample. So I could keep this pretty simple, right? I could do the scores 60 and 70. And then I add them up and divide by how many I have. So the average score was a 65. The mean of that sample of size 2, right? So that was the mean of a sample of size 2 from my population. We could find out all different combinations of samples of size 2, right? This is kind of getting back to the idea of probability. But personally, when I'm not sure what to do, I like to list out all the possible samples, especially when my samples are this small. I could have 60 and 70, 60 and 80, 60 and 90. I could do 70 and 80. 70 and 90. Which one am I missing? 80, 90? Is that the one I'm missing? Okay. So these are my 6 possible samples. Remember, if you think about it, you're doing 4 choose 2. You guys remember kind of doing that stuff? If you're talking about combinations, I know this is something that a lot of you missed in the spring. But we can find all of our possible sample means. This would be 75, right? 150 divided by 2. Okay. You guys check my math on that. Does that look right? Hopefully. So once again, we have all of our different possible samples of size 2 listed with their averages. So if we're going to make a dot plot using the sample means, I always start with my number line. I don't know why that makes the most sense to me. I'm going to count by 5s. And if we were to label the bottom, remember these are the average scores where our sample size was 2, right? If we took 2 students from the population of 4. And we can create our dot plot. We had a score, average score of 65, 70, 75, 80, and 85. Right? If we were to give this a title, this is where we're going to get our fancy new sampling distribution definitions here. So this is actually a sampling. We'll get to the definition in a minute, but this is a sampling distribution of our averages, so of X bar, where our sample size was equal to 2. Remember, X bar represents the mean score of a sample. That's different than the population mean that's denoted by mu. It's the little like M that looks funky. So we'll get to that in just a second. So this is what we call a sampling distribution. The definition we're going to talk about in a minute is it's the distribution of all possible samples from your population of this size, right? We talked about these are the only 6 options if we're pulling 2 numbers from that population, right? So since we have all 6 dots on our distribution, that means we've covered our bases for all possible samples of size, right? So that's why this is represented by a sampling distribution. Remember, an individual dot represents, in this case, 1 sample. Size 2, whose average score was a 65. Right? And if you're going to look at this next question, what is the mean of the population? Remember, the population goes back to the original 4 numbers, right? We had 60, 70, 80, and 90. And to find the average of our population, remember, this symbol means the mean of a population. So our population only had 4 values in it, right? So we're going to add up all 4 of those numbers and divide by 4 to get a mean and average score of 75. Right? So this is our average score of our population. If we were to label that on the dot plot right above, do you see how our mean falls exactly in the middle of our sampling distribution? That is not a coincidence. Your population mean should always fall in the center of your sampling distribution if you have certain conditions that are met. In this case, the conditions will have been met, so we were good. We'll talk more and more about those conditions in this chapter and in chapter 8. But we need to get into a little bit of notation and about definitions as well. So we're going to do our important ideas real quick. There are important things that we need to talk about, which are the difference between a parameter and a statistic. And this is something that we talked about a little bit in chapter 4, and it's coming back here in chapter 7 because notation is everything on this exam. You can do everything right in the problem, but if you use the wrong notation, you're going to immediately go from like a 4 to a 2. So, yes, I'll be picky about this, but we're going to work on it together. That's why this quiz, we're going to do practice, 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 right? A parameter is a number that describes the population. I'm going to zoom in a little bit so I can write smaller. I think it's really helpful that they chose a P word for the population numbers and an S word. Statistic is a number that describes the sample. That's sort of convenient. The S's go with the S's and the P's go with the P's, right? So remember, you're only using the parameter symbols if you're discussing numbers that apply to the population. You're going to use the statistic symbols when you're talking about a sample from that population. It's not super common when you have numbers from the population. So more often than not, you're going to use the statistic, or what's it called, symbols. So there are symbols for mean, for standard deviation. I'm going to make a table. SD, I'm saying standard deviation. And then there's proportions we're going to talk about too. So there are symbols for your parameter, or for your population, parameter. And then there are statistics. So remember, your parameter is your population symbols, and your statistic is your sample symbols, right? So you can have, just like we talked about in our example with exam scores, you can have your mean of your population, so those 4 original scores, right? You're going to have to use mu. It's a mix between an M and a U, so mu. I think it kind of makes sense. It's a Greek letter. I think that one actually makes somewhat sense in the world. X bar is what we're used to for mean. That represents a sample statistic, so an average of some sort of sample. When you're talking about standard deviation, you've actually seen both of these symbols in your calculator, and now you know why, right? You're going to have to use sigma for standard deviation when you're talking about your population, and you're going to have to use one of the S ones when you're talking about a statistic that comes from some sort of sample, right? And then your proportions. For population, it's just a P. But for a sample proportion, you're going to need a p hat. So remember the hats we used to approximate the linear regression line? We put a hat over the y. Kind of the same thing with proportions. We're giving it a hat because this is an estimate of the population. Okay, big other concept is this idea of a sampling distribution. Sampling distributions are something that we're going to use quite often for the rest of the year. And what it does is it shows, sorry, my paper is turning over. It shows the statistic found so usually it's a whole bunch of X bars or it's a whole bunch of P hats. In all possible samples of size n. So our distribution was a sampling distribution because we had all of the possible samples, right? If I were to actually do this class and we had 27 of you and you had to find all possible combinations of 2 scores, that would take you a very, very, very long time, right? So a sampling distribution is a lot harder to attain the higher your sample size is, right? So if you don't have all possible combinations, of samples, it's just an approximation. Of the sampling distribution. So if you were to draw a sampling distribution, right, remember that's when you have your number line, you can have your dot plot. Most of the time, sampling distributions have a lot of dots, right? And usually they're centered in the right spot. But the big thing you need to know is that each individual dot represents a statistic from one sample. I use the word statistic from one sample because in our case we found the average scores from each sample of size